Welcome to another video. In this video we will design the Alpha Tauri rear wing flap tip together. So we want to design something that transitions from this wing profile to a flat profile. So first of all, this is our construction. We can see there's half of the main plane with this rollover into the rear wing end plate. You can see there is a flap already and it's a spoony kind of wing. So we have wing profiles that are like cranked up in the center, and we have flatter profiles at the side. If we look at the wireframe, we have our rear wing main plane in the tree and the rear wing flap below, and then each construction has a wireframe and a surface. You can see the different profiles here. So the lowest one is the center profile of the main plane, and the upper one is the flat profile of the side. You reduce the camber of the outside profile to reduce the downforce level there, so you don't have such a high pressure difference and you have less induced drag. So you see we can switch off the wireframe here. Now we go to the flap and we create a new folder, or in CATIA it's called geometric asset. By the way, this is CATIA V6, what you're seeing here. This is industry standard and most of the F1 teams use it to design these things. We now have a folder called rear wing flap tip. So RWMP is rear wing main plane, which is the lower big element, and RWF is rear wing flap. So that's our flap. First of all, we design our surface. So we want to design a surface that defines how wide this feature will be. So let's say we take 20 millimeters for now. We can change this later on, and we will design everything parametrically, just as F1 teams do it. So you have one design, and if someone comes up to you and want to change things later on, then you can easily change it. So here you can see the construction before. Note that every single function here is named, so you know exactly what each function is doing. It also has the advantage that if you copy and paste a certain folder, then you have the same structure and everything renamed in the next one. So it makes things quicker and very easy to use also for other designers that open your file. Here you can see the different profiles that we use in the flap, so in the center and outboard. Usually the high downforce wings that teams use are relatively straight and cranked up until the side, but we have a spoonier version here and create the same tip feature here. So we first of all use a project, so we have the profile of our rear wing flap out of the most outboard section of the rear wing flap on our new section plane for the rear wing flap tips. So this is that profile. And we now create a point on the curve that is closer to the leading edge, but not directly on the leading edge. We do this because if we design the other profile, it will basically be one curved line and a parallel curved line, and we will have a round tip. So if we design such a more complex transition that is creating a lot of stress for the surface, we need to create something in the other section that is similar. So the rear wing flap has a leading edge that is round, so we separate that round leading edge later on and then transition that into the round bit of the other profile. But you will see that later. So we have this point now on the curve. And we can now cut this curve with this point, so we only have the lower section. Okay, so that is exactly the same profile like the outboard profile of the flap, but it's only the lower section. Now we do an offset, and since the trailing edge thickness of our flap is 2 millimeters, we also use 2 millimeters here. And all of that happens on the same support plane. So all of these functions are happening on the same plane. So later on, if someone comes to us and says, oh, I want this feature to be 60 millimeter wide instead of 20, then you can just easily move that plane and everything is moving with it. So now we have our parallel profile. We need a point on each end of that, so we can use it for the further construction. So we do an extremum, so extremum in x direction. And you can see the compass in the lower right corner, so this is the car's compass. X direction is the longitudinal direction, Y is the lateral one, and Z is the height. So we create these points here. Now we need a straight trailing edge and we need a round leading edge. So let's design this now. So we create this circle and we need something that is bitangent and has a point. So it should be tangent to this one and tangent to this one. And we need one of these points, so it's that one. We don't need to give it any radius, it can work it out by itself. So you can choose a full circle, but we only want a part of it. Yeah, so that's that. It doesn't really look tangent, but it is tangent. Later on we can check if it's really tangent. It's just that it's so small that the resolution within CATIA isn't that great. So that is our leading edge of this new profile. So we just call it profile because for the real wing profiles, we also called it profile. So it's always profile and trailing edge. And then together it's the complete profile. So we now create an extrude of this profile, and this is how we can see that it's parallel, that it's tangent, because the lines there at the very front are gray and not black. So it means it's tangent, so it's fine. It's really a bitangent round leading edge. So the profile is fine now. And now we need to somehow transition from that profile, from this pretty fat profile, wing profile, into the other profile. So how can we do that now? We have 2 points at the leading edge. We have 2 points at the trailing edge. The trailing edge has the same thickness, so that's easy, but important is the leading edge. Actually, the suction side, so the lower side of that profile is also the same. So the upper side, the pressure side, will have a pretty extreme transition. So let's have a look at the wireframe of this outboard section of our rear wing flap. So you can see it's section 2. Section 1 is in the center, section 2 is outboard. Yeah, nicely named everything. So very easy to understand. So we now need a point. And it's usually good if you switch off every geometry you don't need for that operation, so it makes things easier. So what we did was we just brought this profile into the other folder, so we can just work within rear wing tips and don't need to do anything else. We create a point now at 150 millimeters of the wing profile. So you can see this join 9 is the profile of the outboard rear wing flap section. So it's always good to bring the construction we need into the folder we are working in right now. Makes it possible to switch the other folders off. And we are only seeing the things we need. We now created a second point around the leading edge. This is important for later, so we can split the round leading edge from the rest of the profile. Yeah, and now you can already see we have 2 points at the leading edge on one profile and 2 points at the leading edge on the other profile. We will now create guides between them and build the wireframe to build this feature. So let's do a new geometric asset. We call it wireframe. always makes sense to tidy things up. So this is all stuff for the wireframe. If it's getting too messy, make a folder, name it somehow, so it keeps the tree quite tidy. So now we create a spline between the lower leading edge point and the other lower leading edge point. We also give it some tangent directions, which should be Y, because the rear wing flap is also tangent to Y on the outboard side. So that's our first guide. We do the same with the upper points, and that's a bit more interesting because there's more curvature. Yes, and now we can already get an idea of how this feature will look like. Also, we need the two trailing edge points from section 2. They're already there. This is the trailing edge suction point and the trailing edge pressure point, so on pressure and suction side. So we just build these points, or these splines between these 2 points. So from pressure point to the other pressure point. The tangency is the same, it's Y again. Yeah, usually we need to flip this around. And now that's our first guide. And then we create our next guide. Okay, so these are the 2 guides at the trailing edge. We have the 2 guides at the leading edge. We also have the profiles. So it already shows you how the feature will look like. And for our outboard new feature, we already separated all the different lines from each other. We now need to do the same thing for the wing profile. So we have the profile here, and now we use the 2 points at the leading edge to separate that. So we use this point to separate the lower part, that is only the lower part. Then we do the same with the upper one and with the leading edge itself. Yeah, just switch everything off you don't need. So just copy and paste that split, because everything we need is in there already. We just flip it to the other side at the other point, and now we can separate the leading edge. So that's it. And now we copy and paste it again, and then flip it to the other side, remove that 1 point, and that's our upper side. So now we have these 3 parts of the profile separated from each other. And here we create a tangency surface for the outside. So for the new profile, outboard, usually tangency surfaces, I always color them in pink and transparent because it's just very obvious on your screen what it is. You don't really need to read it or something. It's not a construction surface, it's just to help you with building this rather extreme surface. So pink and some transparency. If I see something like this on the screen, I know this is only for tangency reasons. Okay, so that's this feature. Now we can basically continue to build the feature now. So these will be 4 separate surfaces. So the upper one, the leading edge one, the lower one, and also the trailing edge. So let's build the upper one first. So we have the wrong profile here. So we need to find the right profile now, first of all. So it should be the parallel, which was the upper one. So we have the upper one of the wing profile, and we have, yeah, let's switch this off, that's always easier. Let's show this, exactly. Okay, now again, so we use the multi-section, then we use the upper side of the profile and the upper side of the other profile. We can see that the directions don't really match, so we flip this around so the direction is the same, and now in this direction we choose our guides just to make sure we don't create any twists or something in the surface. And that is already our surface. But there is no tangency yet, so it looks a bit weird and it's bulging out a little bit. So we can fix this by using our tangency surface on the outboard side. We would also need a tangency surface on the inboard side. So that is the flap surface, which is pressure and suction surface, the P and S surface. Okay, and this is our outboard surface, or the upper one, the pressure side. Now let's build the lower side, and with these two surfaces as tangency surfaces, we can then build the leading edge surface. Because the leading edge is a pretty stressed surface, pretty twisted, and it would need some good supports. It wouldn't create a good surface if you build the leading edge first and then build suction and pressure side. It's usually better the other way around. So build some unstressed pressure and suction side, and then build the leading edge using the other two surfaces as tangency surfaces. So here for the lower one it's the same thing, same tangencies, and that's it. That's a pretty easy surface. It's not very twisted or anything. And now with these two surfaces we can build the leading edge. And the good thing about the leading edge is now that we have 4 tangency surfaces, so we can force it into the shape we want to have. So again, we use 2 sections and 2 guides. We go from one round section to the other round section and use our guides in between. And here we use the same tangency surfaces, so the flap surface, the outside tangency surface. And then for the 2 guides we use the surfaces we just created, so the lower and the upper side. And this is our leading edge surface. Now we create a new geometrical set called surface, so we can put all the surface stuff that we just created in that, because otherwise the tree is getting too long. It's always a nice habit to create always like a wireframe folder and a surface folder. Very easy to understand, and it's yeah, just makes everything a bit easier to find. Let's also rename these surfaces so people know what they are. In general, it's a good habit to rename at least key functions. Best thing is to rename everything. And now we also need to create the outside surface, so just the flat wall at the side. So we need the profile and the wall. That's our fill, so this is the side. Now we join everything together and switch the wireframe off. That's why everything is in one folder. And then we can see that everything is tangent, that we want to have tangent. One thing we would still do then is the trailing edge surface, but that would be a pretty easy one. what's interesting for us is now if the tip is tangent to the rest of the flap, so now we just join both elements and you can see that it's tangent because we built everything tangent. The only problem with this feature is now that it's only 20 millimeter wide and it's quite a dramatic change of surface, so we could probably make it a bit wider if you see it here. So the rag box is wider because the main plane is also wider, so we could pull it out a little bit. The good thing is we can now change everything. We didn't pick any functions on the screen. Everything is built in a proper and solid way. So this is what it looks like if we pull it out 40 millimeters. And now let's do 60. And you can see that everything just updates. It's very easy to do. And now we have this very nice feature. You can see that the suction side on the lower side of the wing, which is creating most of the downforce, is staying the same. It's only that the upper bit is changing a bit because of there's so much side flow that you want a trailing edge on the side of this element. And this is why we use these kind of features. It just creates a bit less drag, it's a bit more elegant. And you could now also go on and change the leading edge to be a bit rounder at the side. So just like what we saw at Alpine and Alpha Tauri. But this is the general function of the general process of how you design such a tip feature. Of course, there are always many ways to design things in CATIA, but that's a very solid way and a very robust way. You can very easily change this feature now. And if your CFD shows that any changes are needed, it's not a problem to modify this part. So I hope you liked this insight into F1 aero design, and if you did, please consider to become a B-Sport Club member for more videos like this, and check out my other videos, but also check out my online courses where I explain something like this in much more detail, and you can find these courses with the links below. See you at the next one.